Hello everybody, I hope you all are doing great. I welcome you all to this interesting video on the buzzing terminologies, that is LangChain, RAG and AI agents. Okay, so before we move ahead to discuss these terminologies or what they are, let's try to spend some time, a minute or so, to understand how the existing system is working or they are working, right? So for example, if we take a travel booking application, okay, so in that case we will have a front-end client application, okay, that is going to interact with the back-end application. For example, if let's say there is an API that is requesting a source and the destination, and in response it is helping us with the price and the distance between those two. Okay, so how the request will go ahead here. So the client will send the source and the destination, that will hit the backend API. So the API will then further process that request and apply the business logic, and then it will get the data from the database, or it will call the upstream or downstream system if it is needed, and then finally the response is returned back to the client with the price or distance. So this is very what we can say a predefined response, right? So if for a particular request, we will be sure that we'll be getting this particular response. Okay, so I hope you all agree with that. And that is how the existing or the traditional backend systems are working, right? But now, since last couple of years, when with the emergence of the LLMs like GPT or Gemini or the cloud from Anthropic, so the response has been changed, right? For example, if we ask any questions to these GPTs, the response that we get from them is predictive and dynamic, right? So basically these models are trained on large set of data, and they are adjusted according to the proper response. That is, whatever the questions we'll ask, according to the question, the model will predict the next token or the response, and then finally we'll get that response. So that is the reason for, if you have observed, for a particular question, every time we will definitely going to get some different response, though the meaning remains the same, but the response gets changed, right? That is because that's how the model behaves or works, right? So now these are the two different scenarios. So initially we had a static request and response kind of scenario, and with the emergence of LLMs, we have moved from static to the dynamic response, right? So now when we combine these two systems, that is the traditional client server architecture with the emergent LLM architecture, that gives rise to the LangChain. Okay, so if we go ahead with the definition of LangChain, so it's nothing but a framework that helps to build the system using LLMs by connecting it to the external data, tools or systems. Okay, so basically here what we say LangChain is about, that is nothing but it's a framework that helps to build the systems like this travel booking application. But the difference here is, within this system, it will help us to integrate the LLMs, and it will help us to connect that to the external data, tools or the systems if needed. Okay, so this is a simple definition or an understanding of what is the difference between the traditional system or the existing system and the LLM. Okay, so post this integration, how the system may change or behave. For example, now let's say again the same API is called, that is with the source and the destination, but this time, apart from getting the price and distance, the user also gets some other data. Let's say, for example, the user wants to travel from Bangalore to Mysore, okay, and he wanted to know price and distance, but now the user requirement has changed, and he also wanted to know what are the places he can visit in Mysore, what are the foods he can explore, or what is the current weather, and what is the right time to visit there. Okay, so these are multiple questions that the user has, and he wants the response. So now these things, how it could have been solved earlier. So for that, we need to collect the data statically, and then we need to store in the database, and we need to fetch it separately, and we need to send back in the response. But now with the help of LLMs, if we integrate that, then all these additional data which the user wanted can be generated at the runtime or dynamically, and that can be sent back to the user. Okay, so that is how the systems will change with the integration of LLMs. Okay, so now let's see a simple example how the LLM can be integrated, and that can give rise to the LangChain. Okay, so now let me help you to understand the beauty of LangChain with a simple demo. Okay, so for that I have created a simple Spring Boot application. Here I have added some dependencies that will help us to create the LangChain, that is this dev.langchain, and again another one, LangChain OpenAI. So these dependencies will help us to integrate the LLMs into the application that will give rise to the LangChain. Okay, so now here to do this, first of all, I have created a controller with an API, that is AI/ask. So here we'll be sending our request, and that will be sent further to the assistant service. So here in the assistant service, I have added a simple code. Now what does that do? So here first of all we need an OpenAI API key. So here you can either use OpenAI API key or any other API key that you have. For example, you can go with Gemini or any other LLMs, or you can also go ahead with Ollama if it is there in your local machine. You can just hit that LLM also if it is needed. So here it is going to take the API key and the tool. So this is a tool that I have created just for the demonstration purpose. So this tool is nothing but that is going to return us back the current time of the system. Okay, so this tool is created with the help of LangChain.agent.tool, and over this tool we need to first give this description. So this description is something that gives the identity to this tool. Okay, so reading this description, the LLM will understand what is the purpose of this tool. Okay, so here now this tool, what I have given the description is get current system time. Okay, so this will be fed into the LLM, and LLM will have the memory that if the user is asking about the current system, time of the system, then this tool can be used. Okay, so this here first of all I have created a component, and so that this time tool can get integrated as a bean when the application starts, because this is a Spring Boot application. And inside that I have created this tool using this annotation, that is add tool from the LangChain. Okay, now this tool I have added it inside the assistant service. Next, so inside this I have first integrated the language model. So here I am using GPT 4.4.1 mini, and I have added the API key in the application.yaml. So you can just add it over there, and from there I have referenced it over here. Okay, so this is the model that I am going to use, that is LLM model. Next, in the line 40, I have added the code for the memory. Okay, so as we start to interact with this API, I have made sure that within the memory it will store the last 10 conversations. So here we'll get a simple context window to interact with the LLM, and this can be changed according to the requirement. Okay, and next finally here I'm initializing the assistant with the AI service.builder. I'm using the builder pattern here. So here first of all I need to add the chat language model. So the model that I have added it over here, then the chat memory and the tool that can be used if it is needed. Then finally it is building that AI service. Okay, so now once this API or this function is called, it is going to call this chat, and it is going to give us a response. Now how the flow will work here. So let me just show you the API. So this is the API that is going to call, and I'll just first run this, and then we'll discuss how the flow is working. Okay, so I have started the application. Now if I go to Postman, and here I have already added a query that is we are going to ask. So if I hit this, so you'll see that we got the response. So the current time is approximately 12:24 p.m. on December 23, 2025. Okay, and it also telling me about the brief explanation about knowing why the time needs to be known to the people, right? So this is how we are getting the response. Now you may think that what's the difference here? Like we can just ask this question to the ChatGPT and it may also return us the same response. But the difference here is that the usage of this time tool. So if I go to this time tool, you will see that this line got logged. Okay, so what does this mean? When the question got asked to this assistant, then here the LLM has processed it in a stepwise manner. So first it would be taking this whole question, okay, and then it has analyzed that whether any of the part of this question can be answered through the any one of the tool. Okay, so it is like an intelligent brain that is thinking that what can be done or how to get the proper response for the given query, right? So that is the reason while it is processing this, it has found that one of the part of this question can be answered or can be done with the help of the tool. So that is the reason it has internally called this tool, and that's the reason we are getting this logged here and getting that response. And if you see that the response that the tool has given or the return is in this format, right? But what we can see over here is in a very human readable format, right? So what does this mean? Once the response came back from the tool, that response is again fed into the LLM, and finally it has formatted it in such a manner that can be easily read by the humans, and finally that's the reason we are getting back this response. Okay, so that's a simple example of how we can integrate the LangChain along with the other tools that will help us to get the proper dynamic response. Okay, so this is a very simple and the basic example of a LangChain. Okay, next we'll see how we can integrate the RAG into the same LangChain and we can enhance our response in a more better way. Okay, so next let's understand what is RAG, and then we'll see how we can integrate that into an existing LangChain. Okay, so here RAG stands for Retrieval-Augmented Generation. So the RAG basically consists of three parts. That is, the first one is embedding model, then embedding store, and the retrieval. Okay, so first, what is an embedding model? So an embedding model is something like a converter that will convert the data fed, or it can be a document, into a vector store. So what's a vector store here? Vector store is nothing but a list of floating point numbers. So let's try to understand this with an example. Let's say the data that we want to store, or the data that is present inside the document, is like this text format. So for example, now that text will be converted into these kind of floating numbers. And why? The reason is because the computers cannot understand the meaning of the exact text, but they can compare the mathematical patterns, right? So that is the reason. In the first step, when we use the RAG, we use an embedding model. So that model is fed with the actual text data, and it will convert that into the floating point numbers, and those numbers will be stored in the vector store. Okay, that will help us in the later on for the comparison and get the relevant data. Okay, so that's the first step where we'll use an embedding model that will convert the raw text into the floating numbers. The next component here in the RAG is the embedding store. So once this data or the floating point numbers are generated, they needs to be stored, and to store that we'll be using this embedding store. So here it will store all the embeddings plus the original text. So it will store it in this format. For example, for the first document that has this text, it got stored in this format, right? So the text snippet is this, and the embedding store is going to store it in this format. So this is the second component that is needed to store the data. The first component was to convert the data, right? And finally we'll have a retriever. The role of retriever is to get the relevant text or the chunks from the embedding store. Okay, it's very simple, right? The first component was to convert the data, second component was to store the data, and the third component is to retrieve this data. Okay, so how does it works? It will take the user query, whatever the query will be sending, it will convert that query also into the embeddings, then it will compare the embeddings with the existing embeddings present in the store, and finally it will retrieve that back and gives us back the response. Okay, so this is the final code of the retriever, where we are defining the max results as 2. Okay, so at max it will return us the 2 embeddings from the store. Okay, the most closest embeddings compared with the whatever the query that is sent by the user. Okay, so let me just show you the final code, how it will looks. So here I have just added the code within the existing code. So earlier, as we saw, we just had the model and memory, and that we have integrated into the service. But now between this, we have added the RAG system. So in the RAG system, as I said, as we just now discussed, the first one is embedding model. So here I'm again using text embedding model from OpenAI, and with the same API key, we'll be calling this model. So this model will be fed with this data. So this data consists regarding some LangChain, and here the thing that you should notice is the last document, where I have added some dummy data, which we do not find it on the internet, because this is something duplicate data, which is not the right one, but I have added it just for the testing purpose, that I will test it in the next when we'll be hitting this API through the Postman. So what does it say? A lesser known internal milestone, that is the first working prototype of LangChain was jokingly named as Chai Chain. Okay, so this is just I have added it. This does not make any sense, or it is not present over the internet. Okay, so by the development team, because they built the earliest version during late night coding sessions over cups of Indian masala chai. Okay, so this is the document or the text that will be converted into embeddings, and then here we are doing that conversion, and then that will be stored inside this embedding store, and then finally we are adding that into the retriever, and we are integrating that retriever into the service. Okay, so now finally this service consists of the chat model, the chat memory, which it will be storing, then the content retriever, that is nothing but the RAG. So this is where we are integrating the RAG into the existing LangChain, and then the existing time tool, which we already discussed, and finally we are building it. Okay, so now this is a second step on the LangChain, where we have added the RAG along with the external tool and the model. Okay, now let me just run this, and let's test this, how it will work. Okay, so our application has started. Now let me go to the Postman. So here, let me just first ask a very simple or out of the context question, that so that we'll just build up some memory. Okay, so let me just ask that what are some iconic places to visit in India? Okay, so now this is a question that the LangChain will neither able to find it in the RAG, neither it will be able to find in the previous conversations. So finally it needs to get that from the LLM model, right? So that's the reason that will build one conversation, and that will help us to test it in the next API call. Okay, so let me just send this. So here you can see it has returned me all this data, that is Taj Mahal, Jaipur, Varanasi, right? So all these are some iconic places that we can visit in India, right? Now let me just go to the next API call, where we will see that all the 3 or the 4 components of the LangChain will get used in a single API call. Okay, so it is going to use the previous chat memory, it is going to use the LLM, it is going to use the RAG, and it is also going to use the tool. Okay, so let's hit this. So here, what is this query is about? So here we are asking, what was the original internal nickname for LangChain4j? So this the information or the answer for this query is not present with the LLMs, because it's something that are fictional, right? I have just created the nickname. This nickname is not present in in the original text of the documents, right? And then, so from where this, it will going to get this, if it answers this, then it is definitely, it is going to get it from the RAG, right? And then why did the team choose that? Okay, so this is again there in the RAG, the data which we have fed. And then using your own creativity, write a short humorous poem inspired by that nickname and its origin. Okay, so now this again, we don't have this data regarding the poem, so definitely now this is going to be generated using the model. Okay, and then finally, based on the chat memory, briefly summarize the themes of my last few queries. Now to answer this one, it needs to get the data from the previous queries. So with this one query, we'll see that if we get all the expected answer, that means then it has used all the different components to answer this query. Okay, so let me send this and let's see what is the response. Okay, so just one point to add here. By the way, we have not used the time tool because we have not asked any question in this. So I don't think time tool will be used, but let's say what is the response. So here you can see original internal nickname for LangChain4j was Chai Chain, right? So now this is absolutely right. And it has retrieved this from the RAG documents, right? And the team choose this name because they built the earliest version during late night coding sessions fueled by cups of Indian masala chai. So this we already saw, right? And next we asked it to, using your own creativity, write a short humorous poem inspired by that nickname. So it has come up with a poem that is, in the quiet hum of midnight serene, a team brewed up some code with chai's sweet cane. Lines of Java danced on screens so bright, fueled by masala's spicy might, right? So it's again a humorous poem. And finally, what we have asked it to, based on the chat memory, briefly summarize the themes of my last few queries. So for the as for your last few queries, the themes revolved around the iconic places to visit in India, highlighting cultural richness and travel destinations, and then internal culture, creativity, spirit behind the development of the LangChain. Okay, so it has just combined our last two queries and finally summarized that. Okay, so with this, what we can conclude that the LangChain is working, LangChain4j, the whole framework is working perfectly as we expected. So it is basically using the language model, chat memory, and the RAG. And this time it has not used the tool because our query did not had any such question that needed to be answered using this tool. Okay, and here you may be getting one more question, that is, why are we using the RAG, right? Because whatever the data we are feeding here into the embedding store, this can also be generated from the model, right? But this is not the case in many places. For example, in organizations like hospitals or the banking applications, so they will be having their own proprietary and private data, right? And they don't want that data to be fed into the model for training, but they want to use the LLMs on top of that to get the proper information or to get a more understandable information, right? So in such cases, RAG is the best option to get integrated, where they can fed that data into the RAG embedding store, and that will be their private store where the data will be within their infrastructure, and that will not be fed into the model, but we'll be sending only the chunks of data that are needed to get a proper response to the model. And with this, the data remains safe, and on top of that, they can also use leverage the power of LLMs. Okay, for such cases, RAG can be integrated. Okay, so I hope you were able to understand this whole flow of the LangChain. Next, let's see what is a AI agent and how we can integrate that. Okay, so next, let's see what is an AI agent with a simple example. And before that, let's understand what is the core difference between LangChain and an AI agent that we have already just created. So here, as we know, what is a LangChain? So LangChain is something that was working in a predefined workflows, right? So we had an LLM, we had a vector database, that is RAG, then an API tool, then we had a calculator as a tool, and then or the other custom functions. So these all were integrated and we were using the query, and the LLM was basically using them whenever it is needed, and it is getting back as the response, right? So it focuses on the building structured applications by connecting models and tools. So developer basically defines this path that we have already just now saw it, right? But now how it is different from an AI agent. So the basically here AI agent is like an autonomous execution of the task, where the agent itself will decide which tools to use and how to reach that goal. Okay, so basically it reasons. It's like our human brain, where it will reason every step, like after this step what it has to do, which tool it needs to call, how it has to process it. It just goes to and from while generating the response. Okay, so here let's first take one example of an agent. Let's understand that how that agent works, and then we'll look at a simple demo of that. Okay, so for that, here we will take example of a ReAct agent. Okay, so this is an agent, and that stands for reason plus act, that is built using the LangChain4j plus OpenAI, that can be cleanly wrapped inside the Spring Boot application. Okay, so here this ReAct agent has a couple of key parts. The first one is where we create this, and here we define a system message. That is, we tell that what kind of agent it is. So you are a ReAct agent, use step-by-step reasoning, think before responding, use tools when needed. Okay, so this is a simple system prompt that we are giving it. Then here, what does this do? This defines how the AI should behave, sets the rules for the reasoning, and this will encourage the model to think step by step, decides if a tool is needed, then answer it. But the important thing is the reasoning happens internally. We cannot be able to see the we can only able to see the final answer. Then the second thing is ReAct agent service, where we'll integrate this. So again, here first of all we need a model, LLM model. So here we'll be using an LLM model that we have already seen, and then we also need the memory to keep the context in the conversation, and then we'll integrate the tools that we need for this agent to work better. Okay, and finally we will have a ask method that will call this agent to do its work. Okay, so let's look at in the code. So here I have first created a ReAct agent interface, and in this interface we have added this a method, and here we have added the system message. So this we are integrating over here in the ReAct agent service, and here we, as I said, we just now saw we have added a model and the memory, and then we have added it inside a builder, that is ReAct agent with the language model, chat memory, and the tool. Okay, now let's look at how it behaves at the runtime. How or what are the parameters that can tell that this is acting as an agent. So for that, let's take a couple of examples. For example, if we send this query of summation, that is 12 plus 18 plus 25, then how the flow goes. First of all, the LLM will read the question. Then it thinks that this is an arithmetic operation, right? So for that, we have already integrated a tool. So it will call that tool and returns the result. Okay, so this was a tool driven answer, we can say, but at the end, it's an agent that is taking the action. Okay, but here you may say that this already we were doing in the LangChain, right? Yeah, I agree with that point, but let's take the next example. So here, this is an always question where we are asking that what is the event driven architecture? So now this is again a completely an LLM based question. Here we can't use any tool. So here it will just get the data from the model and it will return us back. Okay. And the next example here, if we use this is where we can see a true agent behavior. Why? Because here we can, what we are asking first, what's the current time, and add 15 minutes to it. Okay. So here getting the current time and adding 15 minutes to it is two different operations, right? First, it will call the time tool and it will get the current time. And then it will call the math tool and it will then finally combine the results, right? So basically here it needs to think, it needs to take two different operations. So first it has to call the time, and then it has to, it will think that now it has the time And now the next operation it has to do is to add the 15 minutes to it, right? So here it will think and then it will call the mat tool. So this is a very simple and a basic example where we can see a true agent behavior, and we'll see a quick demo of that. But here now, why this is not just a LangChain? Because without agent, we explicitly decide that when to call the tools and which tool to use. Okay, and we had the hard coded logic. But with this agent, now the LLM will decides, and the tools are discoverable and the behavior is adaptive. Okay, so let's look at a demo of this. So here, this for this I have created a separate controller, that is agent controller, and here we'll be using this ReAct API that is going to call this agent. Okay, so for the demonstration purpose, here I'll be using this query where what we are saying, what is the current system time, then add these two numbers, and finally tell me whether the resulting sum is greater than 12,000 or not. Okay, please show your reasoning step by step. Okay, so now if you send this, you'll see that a true agent behavior can be seen here in the response. So it's the current system time is this, and next I added the number these two, which resulted in this, and then it did a comparison. Finally I compared the sum. Since 12313 is greater than 12,000, the resulting sum is indeed greater than 12,000. Okay, so I hope you are able to understand how the agent is behaving here, where it is autonomously taking the decisions to which tool needs to be used and how to proceed further. Okay, so that's all regarding the overall discussion we need to do here regarding the LangChain, RAG and AI agent. So this was just an high level overview video on these topics. So on top of this, by taking the understanding of this, we can build upon the other real production requirements. And I'll put this source code into the GitHub repo, and I'll put that link in the description, so you can just refer the code over there. So yeah, thanks a lot for watching this video.